car absolutely hunt for the apex. This is the Lexus LF-A, pushing the absolute limits of grip on a racetrack. What you are looking at is the Nürburgring package. Notice the fixed carbon fiber rear wing and the aggressive front canards. These specific aerodynamic additions drastically multiply the downward force pressing the tires into the tarmac at high speeds. To capitalize on that extra grip, the engineering team introduced a remarkably stiffened suspension geometry, swapped in custom lightweight wheels to drop unsprung mass, and flashed the automated transmission to execute faster, more aggressive shifts. But getting a Japanese vehicle to this level of track dominance required a 10-year obsession. Rewind to the year 2000. A small, specialized team inside Toyota initiated development under the internal code LF-A, standing for Lexus Future Advance. Their mandate was incredibly steep. They needed to engineer a halo vehicle from scratch, a car capable of shattering the brand's reputation for making quiet, comfortable luxury sedans by going head-to-head with the best exotic sports cars from Europe. The resulting project took a full decade to finalize. It reportedly cost far more money to develop than it ever recouped in sales, and upon its eventual release, it struggled to find buyers. Yet today, the LF-A is considered a flawless automotive benchmark. It achieved this status because its creators flatly refused to compromise their engineering targets, choosing instead to invent entirely new material sciences and completely rethink how a powertrain should behave. To understand how they achieved those dynamic targets, we must look underneath the aerodynamic skin at the physical layout connecting the axles. The heart is the 1LR-GUE, a bespoke 4.8-liter V10 pushing roughly 552 horsepower. Lexus enlisted Yamaha to help co-develop the block. The instruction was to build something that operated exactly like a dedicated racing engine, which meant forcing massive displacement into an incredibly compact, lightweight footprint. By engineering the internal components with exceptionally low rotational mass, the engine responds to throttle inputs almost instantaneously. It spins up so quickly that it can hit its blistering 9,000 RPM redline in a fraction of a second. That precise mechanical friction and rapid firing order are exactly what generate the LF-A's legendary acoustic profile, a howling, high-frequency exhaust note tuned to mimic a Formula One grid. However, dropping a massive 10-cylinder block over the front wheels introduces a severe dynamic penalty. It makes the nose heavy, which inherently ruins steering response. The engineers solved this by severing the transmission from the engine block entirely. They pushed the 6-speed automated single-clutch gearbox to a rear-mounted transaxle. By isolating these massive mechanical components at opposite ends of the vehicle, they physically forced the mass to balance out, hitting the precise center of gravity target required to make the car handle exactly as they wanted. But a perfectly balanced powertrain is useless if the chassis holding it together flexes under cornering loads. If we look at the early development timeline, the initial LF-A concept debuted at the 2005 North American International Auto Show. At this stage, it relied entirely on a traditional aluminum space frame. By 2007, a second concept appeared. The body lines were heavily refined and dimensions manipulated to be closer to a production-ready vehicle. Yet internally, the engineering team hit a wall. They concluded that no matter how they braced the aluminum structure, it was too heavy and lacked the necessary torsional stiffness for their handling goals. This data visualization compares the initial aluminum frame against a carbon fiber monocoque. The carbon structure yields a massive drop in mass while eliminating flex. They scrapped aluminum for polymer. Carbon fiber would ultimately make up roughly 65% of the vehicle's mass. With a vastly stiffer and lighter foundation secured, Lexus spent the bulk of 2008 and 2009 aggressively hot-lapping prototypes at the Nürburgring, dialing in the precise handling geometry. But there was a glaring mechanical roadblock. Toyota's entire corporate infrastructure was built to stamp steel and aluminum. They had zero existing facilities capable of weaving and curing massive, complex carbon fiber tubs at a mass production scale. Rather than compromise, Lexus chose to pause their timeline and develop their own proprietary carbon weaving looms in-house. That singular decision to control the material science from scratch is exactly what allowed the LF-A to corner with such precision. Of course, engineering a carbon composite structure is one thing. Actually manufacturing it requires an entirely different operational logic. Production finally greenlit in December of 2010, housed here at the Motomachi plant in Japan. Toyota is famous globally for defining the modern moving assembly line. The LF-A facility had absolutely nothing in common with it. Instead of moving a chassis past hundreds of automated robots, every single LF-A was meticulously hand-built from the ground up by one specific master technician. To maintain quality control over the intricate carbon layups and engine tolerances, Lexus capped the total global supply at exactly 500 units. That painstaking attention to detail meant the factory was bottlenecked to an output of roughly 20 cars per month. They completely inverted their own corporate manufacturing strategy, choosing an impossibly slow output rate because it was the only physical way to guarantee the aerospace-level tolerances required by the drivetrain and carbon tub. When you combine the front-mounted V10, the rear-mounted transaxle, and the ultra-stiff carbon fiber monocoque, the resulting machine is incredibly potent. Drivers point to the intense, manual-like mechanical feedback, the flawless, naturally aspirated acoustics, and the absolute rigidity of the chassis as the reasons it remains highly coveted today. The 10 years it took to build this car is often cited as a failure of planning. It was not. It was the absolute minimum time required to engineer, test, and manufacture entirely new material processes from the ground up. The LF-A bypasses its initial slow sales to stand as a definitive technological statement. It proved exactly what happens when Toyota dedicates its vast resources to building a world-class exotic sports car from absolute first principles.